So by the merging of the electron, by merging of electron like orbital, how we can say or how this sigma bond or pi bond will produce, that is coordination bond types, how it will form. So in your coordination bond, you have two types. One is your sigma bond. One is sigma bond and second one is pi bond. Okay. Second one is pi bond. So first one is your sigma bond and second one is your pi bond. So these two bonds will comes under covalent bond. Okay. So now how these bonds are going to be formed, how these bonds are going to be originate. So you can see the sigma bond formation in two types, either SS overlapping, okay, either SS overlapping, or else you can see, it means to say it's a orbital hybridization. ಅಂದ್ರೆ SS ಆರ್ಬಿಟಲ್ಗಳು ಸೇರಿ S overlapping ಆಗಬಹುದು ಅಥವಾ it's of PP overlapping. Okay, either SS overlapping or PP overlapping. Okay, so now SS overlapping with the PP overlapping, if the S orbitals are going to be merged or it's going to be overlap or coincide, so that is called SS hybridized orbital. If P orbital are going to be hybridized or correlate, that give you PP overlapping or PP hybridization. So now let us see the structure, how it going to be merge or how it will interact. So SS orbital anta bandre, so this is your S orbital and this is your S and one more S orbital. So let us give the name of S1 and S2 orbital, so for the better understanding. So SS orbital merge adaga, it will be like this. This one is S1, S2. So this is called hybridized zone. Hybridized zone. So the zone of interaction of two orbital from the different atom, it will give you an hybridized zone. So this is the SS overlapping. So PP overlapping anta helidre, you can see SP overlapping also. So SP overlapping kuda ide. One S is going to be overlapping with one P. So this is S and P. SP overlapping. This is S and P overlapping. Okay. So same like that, you can see PP overlapping. PP overlapping. And alva. So this is we have three types of P orbitals that based on their axis. So how you are going to write, based on that we are giving the name for this. So PP hybridization or PP overlapping. So artha ಆಗ್ತಿದೆಯಾ? This is SS, S with P, P with P. So this is S2 hybridization, this is SP hybridization, this is P2 hybridization. Okay, clear? Easy there. So this and all concepts are easy. So this single merging, so ಇಲ್ಲಿ zone ಇದೆಯಲ್ಲ, so ಇದು ಒಂದು zone, ಒಂದು ಮಾತ್ರ interaction ಆಗ್ತದೆ. In a one point it going to interact. So that will form a single bond, that is called sigma bond. If the orbitals are interacting in one zone, in one side, so that will give you formation of single bond, that is called sigma bond. Okay, so aita next pi bond hogla. Let us move on to the pi bond. Shall I move on? ಬರ್ಕೊಂಡ ಮೇಲೆ ಹೇಳಿ. You just write it and tell me. Okay. Everybody finish? Fine. So now let us write pi bond. So pi bond ಅಂತಂದ್ರೆ it's either a double bond or triple bond. So for that you have one example ಕೊಡಬಹುದು. So we can give you the PP hybridization. So PP hybridization ಅಂತಂದ್ರೆ it will be like this. So you can see the interaction of orbital in two zones, in two regions. ಎರಡು ಝೋನ್ ಅಥವಾ ಎರಡು ರೀಜನ್ ಗಳಲ್ಲಿ ಹೈಬ್ರಿಡೈಸಿಂಗ್ ಸ್ಪೇಸ್ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ PP overlapping. So we can write ಇದನ್ನ ನಾವು if you are seeing in structural representation ಅಂದ್ರೆ ನೀವು ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲಿ ಅಥವಾ ಅದರಲ್ಲಿ ಅಂದ್ರೆ ನಮ್ಮ ನಾರ್ಮಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲ, ಇನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ if you coded here, sigma bond is single bond, pi bond is double and triple bond. So this one electron microscope ಅಲ್ಲಿ ನಾವು ಅದನ್ನ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ರೆ you can see it's a banana shape structure, two banana shapes ಈ ತರ ಕಾಣಿಸುತ್ತೆ ಈ ಬಾಂಡ್. So this is double bond, this is pi bond formation. Can you send the pic? I'll send pics ಕಳಿಸ್ತೀನಿ, don't worry. Okay, then which one is more stronger among the strength of sigma and pi bond? ಸಿಗ್ಮಾ ಮತ್ತೆ ಪೈ ಬಾಂಡ್ ಗಳ ಮಧ್ಯೆ ಇರುವಂತಹ ಸ್ಟ್ರೆಂತ್ ಯಾವ್ದು ಜಾಸ್ತಿ? which one you can say having more strength and which one is having less strength? So in these two, sigma is more stronger because of sigma bond is more stronger. It is a single bond because it is a complete merging. So the merging area or the orbital hybridizing area or e space ಇದೆಯಲ್ಲ, this space is going to be more because of the complete overlapping of the orbital. This bond is going to be stable. ಸಿಗ್ಮಾ ಬಾಂಡ್ ಪೈ ಬಾಂಡ್ ಗಿಂತ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. Why? Because the hybridized zone is completely hybridized or it's completely overlapping. So that's why to make or to break sigma bond you required more energy. Okay, so hybridization means it's an overlapping of your orbital. Hybridization. Okay, hybridization next topic idu. Hybridization andre it's an overlapping of orbitals. Overlapping of orbitals. So this hybridization will gives you the so idradu ಒಂದು silent features ಇದೆ. What are the can you repeat it? Stronger sigma bond. Sigma bond is more stronger because the hybridizing zone or the overlapping is completely overlapped. ಅಂದ್ರೆ ಈ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಎಲ್ಲ ಹೇಗಿರುತ್ತೆ ಅಂದ್ರೆ ಈ ತರ ಫೋರ್ಸ್ ಎಲ್ಲ it will completely move inside and it will completely merge. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ಇಷ್ಟು ಝೋನ್ ಆಗಿದೆ ನೋಡಿ, ಇಷ್ಟೊಂದು ಓವರ್ಲ್ಯಾಪ್ ಆದಾಗ it is difficult to remove. But if in case like this, if it just touches each other, we can remove easily. So that is the topic or concept we can explain in terms of sigma bond and pi bond here. Sigma bond to pi bond ಇದನ್ನ ಇಲ್ಲಿ ಕಂಪೇರ್ ಕೊಡಬಹುದು. ಓಕೆನಾ? ಸೊ ಹೈಬ್ರಿಡೈಸ್ಡ್ ಸೈಲೆಂಟ್ ಫೀಚರ್ಸ್ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, the number of hybrid orbitals is equal to number of atoms orbitals get hybridized. ಸೊ ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಗಳು ಹೈಬ್ರಿಡ್ ಆಗಿದೆ ಅಂತ ಅನ್ನೋದು ಎಷ್ಟು ಆಟಮಿನ ಆರ್ಬಿಟಲ್ಗಳು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಿದೆಯೋ ಅಷ್ಟು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಗಿರುತ್ತೆ. ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಇನ್ ಒನ್ ಆಟಮ್ you can see the merging of an orbital, it's supposed to be two orbitals are involving in the hybridization. So on the atom alli if two orbitals are involving in the hybridization, it means to say two hybrid orbital will form. How many orbitals are going to involve? So that many hybridized orbital will form. Simple alla. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನನ್ನ ಈ 4 ಬೆರಳುಗಳಲ್ಲಿ 2 ಬೆರಳು ಮಾತ್ರ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದೆ, ಈ ಬೆರಳುಗಳು ಇನ್ವಾಲ್ವ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಏನರ್ಥ? ಸೊ ದೀಸ್ ಟೂ orbitals are involving in the hybridization. So how many orbitals are involving? That many hybridized orbital will form. So these two are not involving, so no problem like that. Okay, so this is the first hypothetics. So that means to say first salient feature. So the second one goes like this. The hybridized orbitals okay, the hybridized orbital are always equivalent in energy and shape. Okay, the hybridized orbital are always equivalent in energy and shape. It means to say, ನಾನು ಹೇಳಿದೆ ಅಲ್ವಾ, ಈಗ 2 orbitals are involving in the hybridization. So those 2 orbitals having the energy will be same. So okay, and the shape remains same. ಈಗ ಈ 2 ಆರ್ಬಿಟಲ್ಗಳು ಇನ್ವಾಲ್ವ್ ಆಗಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, so the energy required to hybridize these 2 orbital is same between this and this, and the shape of these 2 are looking same. ಹೌದಲ್ವಾ? ಸೊ ಇದು ಈಗ 4 ಕಾಣಿಸ್ತಾ ಇದೆ, ಇದು ಒಂದು ಆರ್ಬಿಟಲ್ ಒಂದು ಆಟಮ್ದು, ಇದು ಒಂದು ಆಟಮ್ದು ಅನ್ನೋದಾದ್ರೆ you can see those structure also same, and the energy required to merge, that energy also remains same. So this is the second hypothesis. And third one, the hybrid orbital are more effective in formation of stable bond. So to form stable bond, it means to say if any 2 hybridized orbital will form, if any 2 orbitals are going to be hybridized, ಅಂದ್ರೆ ಈಗ ಇವೆರಡು ಆರ್ಬಿಟಲ್ಗಳ ಹೈಬ್ರಿಡೈಸ್ ಆದ್ರೆ, so this will give you the strengthening of the bond. So how much the hybridized are going to take place, that much stability you can attain in your orbitals. So orbital ಅಲ್ಲಿ ಅಷ್ಟು ಸ್ಟೆಬಿಲಿಟಿ ನ ನೀವು ನೋಡಬಹುದು. ಓಕೆನಾ? Next, last one. These hybridized orbital are directed in space in some prefix direction to have minimum repulsion, because electron pair and stable arrangement, those type of hybridization involving the geometrical and structural shape. So what they were saying means, the orbitals are involving, that orbital contains some electron. Those electrons are not in the condition of repelling. For example, college start, I don't have idea. Maybe the chances of possibilities, but 17th degree ಅಂತ ಹೇಳಿದ್ದಾರೆ, not for PU. Maybe ಈ month end ಅಥವಾ next month starting ಅಲ್ಲಿ they are going to plan for the reopening of the college for 10th and PU. So fourth point ಏನು ಹೇಳ್ತಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, it's a repulsion, minimum repulsion. So if I putting down arrow mark, it refers minimize or reduce or decrease. Repulsion. So it's a decreasing in the repulsion of electron in hybridized orbital. So ಅಂದ್ರೆ ಇವಾಗ ಈ atom ನ hybridization. So this is your atom. So ಈ atomಗಳು hybridize ಆಗ್ತಾ ಇದೆ. So here two orbitals are going to be hybridized. So ಈ orbitalಗಳಲ್ಲಿ ಇರುವಂತಹ electron, the electron present in these orbitals are having less repulsion. Why? Because if it is having repulsion, this orbital will move apart and it will break the formation of the bond. Because of that, the repulsion rate of electron that is present in the hybridized orbital are minimized. Okay, can you able to see? Screen blur. Okay, so ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲಪ್ಪ? So this is the 4 postulates or salient features of your hybridization. So what is the major criteria for making an hybridized orbital? Means to say, we need to hybridize or overlap completely. Orbital ಗಳನ್ನ complete ಆಗಿ overlap ಮಾಡಬೇಕು. Second point, energy should be equal with their orbitals. ಆ orbital ಗಳ ಮಧ್ಯೆ energy ಕಡಿಮೆ ಇರಬೇಕು. And the electron should not having an repulsive character. Electronಗಳು repulsion ಅಲ್ಲಿ ಇರಬಾರ್ದು. So this around all the important condition. If you follow this all condition, you can make the orbital to be hybridized. Then next concept, you have types of hybridization, that is sp, sp2, sp3 hybridization. With the hybridizable structure we need to explain. Then I think so that all three will be of same kind. We'll done or we'll take up the class in tomorrow session, because we have left with only 2 minutes. So 2 minutes only, that's impossible to explain all three hybridization structure. So let us continue it